Hello and welcome everyone. My name is Connor Earls and this is a presentation on the new TechSmith headquarters at Spartan Village. Our company is Mitten Engineering, and let's get right into the presentation. I would like to start off by introducing the team here at Mitten Engineering. I am currently the project manager for this project. Accompanying me in this presentation is transportation engineer Patrick Dempsey, pavements engineer Joe Beatty, hydrology engineer Emily Loftus, structural engineer Anshuman Gupta, and environmental engineer Kayla Seaman. Now for a little bit of background on TechSmith. TechSmith builds software that allows a user to create and share images and videos for better training tutorials, lessons, and everyday communications. Kevin Irwin is the CFO and the executive sponsor for the project. He came to us and he gave us a demonstration showing reasons why they were wanting to leave their current location. They are currently split up between these 5 different buildings, which makes collaboration in person or team meetings pretty difficult for them, especially on bad weather days that hinder them, such as in the cold and in the snow. They are also currently paying rent, which we all know is more expensive than owning. Along with that, they also have higher utility bills due to multiple kitchens, multiple buildings with lights, etc. Along with that, being able to be part of the Spartan community is too good to pass up and brings many exciting things for the company. This is a visual of Michigan State University's master plan. I wanted to get you a little more familiarized with the area. If you see coming down through here, this is Trowbridge Road. If you take a right down Trowbridge onto Harrison, and you come down here to the Southern Crescent Harrison Road intersection, this is where our job site is located. As you can see in the legend up here, Spartan Village area is a building opportunity, and TechSmith is the first and hopeful many companies to relocate here. Spartan Village is an outdated area of MSU's campus, and they wish to bring this area into a greater business complex. Speaking of Michigan State's master plan, these are some of our project goals that are largely taken from it. The visual to our right is a proposed site plan. As part of MSU's master plan, there is a large focus on green infrastructure. Green infrastructure is an approach to water management that protects, restores, or mimics the natural water cycle. Green infrastructure is effective, economical, and enhances community safety and quality of life. Safe and efficient travel is important to Michigan State University, as well as being important to us here at Mitten Engineering. Our transportation specialist will further walk you through on what we have done to achieve this goal. Another important goal is finding a cost-effective and lasting rehabilitation alternative, which our pavement engineer will touch on later. An aesthetically pleasing building is very important because TechSmith will be the first in the business college that is Spartan Village. Our structural engineer is here to work with the architect to ensure this can happen. One of the things that Kevin talked about in his presentation to us was the importance of them wanting to achieve a gold LEED rating, which we are trying to make possible through all of our other design goals. Our final goal is not only the nutrient removal from the TechSmith building, but from the greater East Lansing area. While our environmental specialist is working with us on the TechSmith building, she is also currently working on a project for the greater East Lansing community. Here is a visual showing where the East Lansing water treatment plant is in relation to the TechSmith building. The star is where the new TechSmith building will be, and the square is where the water treatment plant will be. As you can see, they are very close to one another. The East Lansing water treatment plant treats nearly 12.6 million gallons of water a day. The plant does not, however, currently treat for nitrogen removal. The addition of nitrogen removal is very important to the community because it can help decrease algae blooms in the water, which means an improvement of life in the ecosystem, making it easier for animals to thrive. The current service area for the East Lansing water treatment plant is East Lansing, MSU, and Meridian Township. This project was commissioned by the state of Michigan.
Thank you, Connor. I'm Kayla Seaman, and I'm the environmental specialist for the company. The environmental design focuses on upgrading the nutrient removal of the East Lansing Wastewater Resource Recovery Facility. As you can see from this diagram of the facility currently, it does have a phosphorus removal technique, but does not have any mechanism for nitrogen removal. Therefore, a main goal of this upgrade is to achieve 95% total nitrogen removal. Another design objective is to achieve resource recovery within the wastewater treatment process. The treated effluent must meet all wastewater regulatory standards, and the plant design was modeled on Sumo 21 software, which is a model development software for water treatment. The United States EPA provides regulatory limits for wastewater effluent with the Clean Water Act. This was implemented to reduce the pollution being discharged into waterways and to protect the ecosystems that the waterways support. The Clean Water Act requires any point source of pollution into surface waters to obtain a National Pollutant Discharge Elimination Permit. Currently, Michigan does not have any set limits for nitrogen in the effluent, but those with an NPDES permit are still required to sample and report the nitrogen levels of their discharge. In Michigan, with an NPDES permit, there is a maximum allowable 1 milligram per liter monthly average of phosphorus and a range of 6.5 to 10 as an allowable pH. The City of East Lansing Code of Ordinances has a maximum of 12 milligrams per liter daily average of phosphorus and 20 milligrams per liter daily average of ammonia. I completed a literature review researching many different types of nutrient removal technologies in the field of wastewater treatment. From this, I came up with an approach that can achieve efficient nitrogen and phosphorus removal in a way that can generate electricity. This includes utilizing biological processes for nitrogen removal. With an integrated fixed film, activated sludge, or IFAS system, it can achieve nitrogen removal using partial nitrification anammox processes, as shown in this picture. The benefits of this over other treatment methods include lower energy demand, lower oxygen demand, and lower carbon requirements. This can also be achieved using one tank due to IFAS's capability to have different oxygen conditions in different parts of the tank. For BOD and COD removal, I decided to use anaerobic digestion with an upflow anaerobic sludge blanket or UASB reactor. This process produces electricity to offset plant energy use. For phosphorus removal, it was decided that we would continue to use the chemical precipitate method using ferrous chloride. Here is the recommended plant layout. As you can see, our plant uses a three-step process where electricity is generated in the first step, nitrogen is removed in the second step, and phosphorus is removed in the third step. This first step uses a UASB bioreactor to anaerobically digest sludge to produce methane, which can be used for electricity. The second step is the IFAS system, where activated sludge is recycled back into the MBBR tank and partial nitrification and anammox processes are allowed to occur. The third step requires an addition of ferrous chloride in order to precipitate phosphorus from the water. This is removed from a sand filter, and the effluent is released into the Red Cedar River. The main parameters that I changed within the Sumo software were the MBBR tank volume, depth, and airflow. I found that partial nitrification occurred best with high tank depths and low tank volumes. The airflow needed to be sufficient for the partial nitrification to occur on the activated sludge, but low enough so that there was little aeration in the biofilm for the anammox process. Some important parameters to consider include the recycled flow rate, volume of the UASB, and the chemical addition of the ferrous ion. For the recycled flow rate, I increased this value to 500 meters cubed per day in order to increase the efficiency of the IFAS system. The volume of the UASB was increased to increase the electricity output. The chemical addition of ferrous ion was calculated to be 67.56 milligrams per liter in order to supply sufficient ferrous ion to precipitate the phosphorus out, and alkalinity was also added in order to increase the pH of the effluent. The proposed design was able to achieve all of the design objectives and regulatory standards. The effluent characteristics include a 2.4 milligrams per liter total nitrogen concentration in the effluent. This meets the design objective of 95% total nitrogen removal. The 2.4 milligrams per liter of ammonia in the effluent meets East Lansing's regulatory standard of 20 milligrams per liter of ammonia. The BOD and COD concentrations were far below their regulatory standards. The effluent had a pH of 7.1, which was within the acceptable range for pH. The total phosphorus concentration in the effluent was 0.41 milligrams per liter, which met the NPDES limit of 1 milligram per liter total phosphorus as a monthly average. Overall, the impact of this design would be cleaner waters and healthier ecosystems. I also wanted to briefly touch on the importance of sustainability in regards to the TechSmith building. In order to achieve our company's goal of having a LEED Gold rating for the building, there are a few recommendations that I had. Low-flow faucets and toilets can be utilized to help reduce the site's water consumption and wastewater production. Energy-efficient lighting can help reduce electricity usage and electricity cost for the site. Additionally, when using plants and trees for the site, native plants and trees should be chosen. This will reduce the need for fertilizers and pesticides, which are harmful for the environment. Next, you will hear from our transportation engineer, Patrick.
Hi, my name is Patrick Dempsey, and I am the transportation specialist for the company. The main design objectives of my role consisted of performing a traffic impact study on the local roadways and intersections, designing a parking lot following the project guidelines, developing a project site plan, and including considerations for pedestrians and non-motorized vehicles. The figure on the right shows the site location for the project, indicated with the red star. This is located off the intersection of Crescent Road and Harrison Road. In order to understand how local traffic will be impacted by the TechSmith headquarters grand opening, a traffic impact study was conducted. The two intersections analyzed in the impact study were the North Crescent Road and Harrison Road intersection and the South Crescent Road and Harrison Road intersection. Existing traffic volume data and turning counts were taken at the study intersections by Anthony Ingles' CE 341 class. After analyzing the traffic volumes from the counts, the peak hour traffic was determined. The peak hour traffic was modeled with Synchro to provide an accurate depiction of the existing roadway conditions. The no-build models listed above provide data for the intersections without the additions of TechSmith headquarters traffic, whereas the build models provide data for the intersections with the addition of the trips due to the headquarters. All of the build models included the number of AM and PM peak hour trips that would be generated by the proposed TechSmith building. These values were based on data published by the Institute of Transportation Engineering's and Trip Generation 8th edition. The future models used an assumed growth rate of 0.5% per year for all movements and volumes. Lastly, the TIS will provide any necessary recommendations that will help accommodate the projected increase in traffic volumes. Recommendations have been made based on the results from the 4 build models. Adding a left turn lane on Harrison Road at the southern intersection will allow northbound traffic to move freely without having to navigate around cars attempting to turn left. The storage length of 175 feet will provide space for other cars to line up before making this turn. Additionally, a right turn lane for vehicles traveling southbound on Harrison Road is recommended at the southern intersection. While the right turn maneuver is not as challenging as the left turn, the large increase in volume coming from northbound Harrison could lead to backups in the right lane. The addition of a right turn lane with a storage length of 150 feet will provide room for vehicles to queue before making the turn. Lastly, it is recommended that eastbound South Crescent Road at Harrison Road is converted into 2 lanes at the intersection. The left lane will be used for left turns only, and the right lane will be used for right turns only. With the intersection being unsignalized, an increase in traffic volume will significantly back up the flow of traffic out of Crescent Road. Providing 2 separate lanes for each maneuver will increase movement at the intersection and decrease the queue lengths. The provided recommendations were modeled on Synchro to determine whether or not the changes to the intersection will improve the level of service and decrease delays and queue lengths. The intersection level of service for all 4 models was bumped up to an A for the Southern Crescent Road intersection. The intersection prior to the changes was operating at level of service F. Additionally, the 95th percentile queue length from traffic traveling eastbound on Crescent Road was decreased to a maximum of 62 feet. This maximum queue length is 60 feet less than the queue length at the intersection before changes were made. The figure on the slide shows the proposed changes at the intersection. One of the transportation objectives was to design the parking lot for the TechSmith headquarters. TechSmith plans to have 300 total employees, with 250 of them traveling to work on a daily basis. According to East Lansing City Code Ordinances, zoning section 50-812, it is required for general businesses or professional offices to have 1 parking spot per 300 square feet of net floor area. As a result, our company determined 250 commuting employees each needed a space, while also including 19 excess spaces for growth. Each space is 9 feet in width and 20 feet in length, which meets the requirements stated in East Lansing City Code Ordinances zoning section 50-816. Handicap spaces were included based on the required specifications given by the ADA. Out of the 269 spots, 8 are handicapped, with 2 van accessible spots. The 2 van accessible spaces contain a restricted area adjacent to the space, which allows for ease of entering and exiting the vehicle. Lastly, there are 3 electric vehicle charging points located on the easternmost border of the parking lot. These spaces can be seen shaded in yellow on the figure in the slide. Furthermore, these charging spaces are a portion of our LEED contributions. The figure shown in the slide is the proposed project site plan, which was modeled on AutoCAD. This model includes all of the recommendations provided for the Southern Crescent Road intersection. The right turn lane traveling southbound on Harrison Road can be seen here. The left turn lane traveling northbound on Harrison Road can be seen here. Additionally, the left and right split turn lanes traveling eastbound on Crescent Road can be seen here. Mitten Engineering also decided to add a shipment bay and trash collection area on the western side of the proposed building. This is for trash trucks and delivery trucks to pull in, that way they don't affect the traffic for the parking lot. Lastly, you can see all of the hydrology aspects, including the detention pond, the rain garden, and the cistern, all highlighted on the slide. Another one of the project goals was to provide designs considering pedestrians and non-motorized vehicles. The high traffic volume on Harrison Road was not conducive to a bike lane. Instead, the existing 6-foot sidewalk was converted to a 10-foot shared use path. This will allow both bicyclists and pedestrians to travel safely while sharing a designated space. Additionally, bike racks are provided at the main entrance of the headquarters. This works in tandem with the company's plan to provide employees with bicycles, which can be used freely. Lastly, the existence of the bus stop west of Crescent Road driveway will allow employees another mode of transportation for commuting to and from work. The access to bikes and bike racks, as well as the shared use path, contribute to the LEED rating for the overall project. The figure shown in the slide is the non-motorized circulation framework for Michigan State University. Mitten Engineering plans on connecting the site's shared use path with the proposed shared use path Michigan State plans to develop. Next, you will hear from Joe, the pavement specialist.
Hi, I'm Joe Beatty, the pavements engineer for Mitten Engineering. So with the redevelopment of Spartan Village, we are expecting a much higher use of the roads in and around Spartan Village, which means that these roads will soon be in need of rehabilitation or reconstruction, given their current condition, which I'll talk further about in the following slide. The goals of this portion of the project are to rehabilitate the roads in and around Spartan Village and to do so in a cost-effective manner while also still being feasible. So the extent of this project includes 3 roads, which can be seen on the image on the right. First of which is Harrison Road, which will go from the train tracks all the way to Mount Hope Road. And then the next one is Crescent Road, which will be the entire loop that goes around the headquarters, all the way from Harrison Road to the other end of Harrison. And finally, Middleville Road, which will be the extent of the entire road from Crescent Road to Crescent. So here are some actual photos of the road taken back in September. First off is Harrison Road, which can be seen on the left. This road is currently in the worst condition out of the three roads. As you can see, there is some block cracking as well as longitudinal and thermal cracking. And it has recently been sealed to help prolong the life of the road, but ultimately this is just a temporary fix. Next up is Crescent Road, the image in the middle. And as you can see, there's some thermal cracking along the road, and this will really only get worse as time goes on because of the freeze-thaw cycle that happens in Michigan. Ultimately, though, it's in slightly better condition than Harrison Road. And next up is Middleville Road, which is in slightly better condition than Crescent Road. And there is some longitudinal cracking right down the middle of the road, which has been recently sealed just like Harrison Road. So next, the PSI for each of these roads was calculated by 6 individuals driving the roadways and giving each one a grade from 1 to 5, 5 being the best. And these grades were then averaged to get a PSI rating of 2.9 for Harrison, 3.43 for Crescent, and 3.75 for Middlevale. I then used the website LTTP Bind to find the climate data for East Lansing, and it was used with my ESAL calculations to determine the performance grade of 58 to 22. And this is used to determine the type of HMA that I will be using in the rehabilitation process of these roads. The ESALs were calculated using the data in the table on the right. I was given the 2019 average daily traffic data due to the lower traffic volumes in 2020 because of COVID, and used a growth rate of 2% to get the estimated data for 2021. The growth factor was then calculated using the equation on the upper left, and the rest of the data was given by MDOT standards. And from here, all of the necessary data was found or was used to calculate the ESOLs for each road and for both flexible and rigid pavements. So the 4 alternatives to rehabilitate or reconstruct the roads. So this image shows the cross-section of the road for the mill and fill option. The surface of the existing pavement will be milled down, and then a 5E3 HMA will be paved over the top of the milled surface. You have to make sure that tack is used to ensure a proper bind between the old HMA and the new HMA. Without a proper bind, the pavement distresses below will rise to the surface and cause the roadway to deteriorate faster than it should. So finally, my engineer's estimate for the construction cost of the pavements portion of this project is shown in the table right here. And this includes the HMA and base for the parking lot of the headquarters, as well as the milling and HMA costs for Harrison, Crescent, and Middlevale roads. So the cost of the HMA was calculated by determining the area for each section in square feet, multiplying it by the depth of pavement, which was 3 inches for the HMA, and then multiplying that by the cost of 5E3 pavement. And then a low volume super pave was used for the parking lot. So the cost of milling was found by multiplying the square yards by the cost of milling, and an 8-inch base was also used for the parking lot, and the cost is shown in there. Adding all of this together, the total cost for the pavements portion of this project was found to be about $1.4 million.
My name is Emily Loftus, and I'm the hydrology specialist of the company. The main design objective for my role was to create a stormwater management system for the site. The system consists of a stormwater sewer design network leading to a detention pond where stormwater will be held and slowly released to the existing pipe system of the Michigan State University campus. The purpose of creating this system and outlet combination is to improve the quality of the stormwater before it enters the existing infrastructure, reduce the quantity that passes through the network at one time, and to prevent flooding of the site and surrounding communities. Two main goals for the design were to have as many low-impact design features as possible, as well as utilize natural topography and have high infiltration rates of non-developed areas. These goals help to result in a cost-effective system that is efficient and safe for the community. In the design of the stormwater management system, there are various codes and regulations that must be followed. The regulations set by the Ingham County Drain Commissioner Code, MDOT Drainage Manual, and Michigan State University Stormwater Guidelines must be met. For the storm sewer network, the subcatchments must be separated by natural topography of the area, which has to result in junctions that are less than 400 feet apart to allow for proper drainage. The pipes must be able to withstand a 10-year, 24-hour flood concentration rate, resulting in a flow velocity that must be within 3 to 10 feet per second. The pipes must be at least 3 feet below the surface level to ensure no freeze-thaw cycles would interfere with the integrity of the system. The detention pond must be able to withhold one 100-year 24-hour flood event worth of runoff and have an outflow of less than 0.15 CFS per acre, which would be about 0.83 CFS per site. To the right is the conceptual design of the site. It has been broken into 10 subcatchments, each having its own junction. The storm sewer network consists of 4 concrete piping conduits and 2 vegetative swale channels, all leading to the detention pond. The swale was placed in natural areas where the infiltration rates are high, and the pipes were reserved for parking lots where the infiltration rates would be lower. The detention pond was placed at the lowest point of the site to allow for natural flow directly into the pond. There are also many low-impact design features, which include the rain garden, which is placed at the second lowest point of the site, the green roof and cistern combination to help collect rainwater and irrigate the roof, and the bioretention cells in the parking lot, which helps to bring back some of the infiltration that the pavement takes away. Overall, the site meets all design requirements and objective goals for the project. So to start, the storm sewer network calculations were completed. After the site was separated into subcatchments, junctions, and conduits, time of concentration was calculated for each section, and the intensity of the flow using the values that correspond with the 10-year storm event requirements was found. Finally, the overall flow rate of each network section was determined, and the overall flow rate for the site as a whole was found. By using the overall site flow, the conduits were sized via Manning's equation. This was used for both the 4 concrete pipes as well as the vegetative swale channels. To meet all MDOT regulations, the pipes got sized up to the 12-inch diameter minimum while remaining within the velocity range. The swale was designed as a trapezoidal shape to create the most effective flow and also met the minimum velocity requirements. Next, the detention pond was sized. A detention pond was chosen for the site rather than a retention pond due to the cost savings and safety factors. The required volume of the pond was found utilizing the rational hydrograph method. This took the pre- and post-development flow to find the volume of the pond at the 100-year event. From there, the actual pond size was determined to be around 21,000 cubic feet in the shape of a truncated cone. The volume accounts for a 10% increase as compared to the requirement, as this allows for sedimentations to collect properly and to be flowed out. The detention pond was connected to the existing Michigan State University stormwater system, which was found on Harrison Road, and the pond outflow needed to meet all requirements before being connected. The hydrograph shows the inflow versus outflow of the detention pond, as well as the maximum flow rates. The pond was successfully created and never goes above the regulated amount of 0.83 CFS. Lastly, the low-impact design features were accounted for. The two main features that I worked on include the vegetative swale and the rain garden. Both are meant to increase infiltration rates of their given areas and to reduce overall runoff and improve the water quality. By adding these features, the site was able to meet the outflow requirements of the system with ease. Three other features I worked on include the green roof and cistern systems, as well as the bioretention cells. By working with the structural specialist, I was able to create the cistern system that feeds the irrigation for the green roof and helps to collect rainfall during events. Similarly, by working with the transportation specialist, I was able to create the bioretention cells in the parking lot and to help increase the infiltration rates for that area. Overall, the low-impact design features help to make the site more sustainable and add to the overall success of the stormwater management system. Next, you will hear from Anshuman, the structural specialist.
So moving up here on the left, I included the structural layout of the building, which shows the beam spacing, the outdoor patio, and the tentative location of the atrium. The first thing to know here is that this design is based on the architectural plan provided by the MSU. For the design, I went with a steel frame design, which has brace frames, meaning pinned connections. This helps in cutting down the material cost, and also incorporates the idea of sustainability, which I will be discussing later. The flooring was decided to be a composite metal deck with a 5-inch concrete fill to address our client's need on maximizing the natural light entering the building. A 50 feet by 30 feet atrium was decided to be constructed. So here the floor to floor height between the first floor and the second floor is about 14 feet, and between the second floor and the roof is about 15 feet. It is also important to mention about the symmetric design of the building, which came in handy throughout the design and analysis. So moving on to the floor plans, here on the left I have included a structural floor plan of the building. I was only able to include the second floor structural layout, but this gives you an idea of the style, which is pretty much similar for the first floor. We were able to exceed all the requirements as far as having an open office space. I used Michigan Building Code for all the standards and specs, which includes corridor widths, staircases, elevators, and the number of restrooms. The most important feature here to notice is the equidistant placing of the beams and columns, which provides better load resisting capabilities to the overall structure. There are 4 major cutouts on each level, out of which 3 of them are for staircases and 1 of them is for the elevator. The beams are placed approximately 6 feet from each other. Also, another important feature which can be seen in the floor layout is the hatched area in the southwest region of the building, which highlights the outdoor patio. So next up is the roof plan of the building. The first picture on the left shows the first half of the building, which will have solar panels installed on top of them, and the second picture, which shows the other half of the building, will have green roof set up throughout its area. Along with that, we'll have a 50 feet by 10 feet mechanical, electrical, and plumbing unit with a roof hatch for access. So for the structural analysis, it was time to calculate the loadings on the building. We included the self-weight of the members, dead loads, live loads, roof live loads, wind loads, snow loads, the loadings for green roof and solar panels. These loads were given to us by Mr. Eric, our structural engineer consultant, or were calculated manually using the ASCE manual. There were also 7 load combinations that we tried out, and these load combinations almost act as a factor of safety. So SAP 2000 was the software we used to analyze the loadings on our building. It allowed us to create a similar structured model and then uh, apply our calculated loadings onto the model. This is where the symmetry of this structure came in handy. We could design for one typical bay and the loadings would be similar for the rest of them. Uh, so yeah, once that was done, we inserted the loadings and then applied them in the 7 different loading combinations I mentioned about in the last slide, and outputted were the axial, shear, and moment forces for all the members. From there, we were looking to find the highest of all those forces and then design using those forces. With those design forces, we used the procedures taught in CE 405 design of steel structures to get the member design. I also used the AISC manual for all the charts and tables during the design. Uh, you can see the final member design here in the table on the left, and it is important to point out that max forces were used for the design. Like I mentioned, sustainability was our key goal throughout the design of this project. There were a few ways by which we were able to incorporate this idea into our structural design. First off was having braced frames. This just created less internal forces within the members as compared to having a moment frame, and it also cut down the material by up to 40%. Next up was having large window panels and an atrium to allow natural light to enter the building. This could ease the electricity bill during the winters. Sustainability can also be achieved through material selection, such as the steel frame we chose. The steel is local from Lansing and is expected to be 100% recycled steel. Some materials in concrete, such as admixtures of slag and fly ash, which are byproducts from other industries, can be used. Also, use of recycled aggregate for the concrete used in slabs and walls, if the design allows. Lastly, there were some systems that were installed in the building, such as solar panels, green roof, and smart appliances to offset the environmental impact caused by the building. Next up, you'll hear from Connor, our project manager.
Thank you, Anshuman. Now I would like to show you our strides toward the Gold LEED rating. Most of our accomplishments are through hydrology. We have the vegetative swale, the rain garden, the green roof, cistern, and bioretention cell. We have a few additions from environmental as well, the low flow faucets and toilets, native plants and trees, and energy efficient lights. In transportation, we have a shared use path and electric car charging ports, and from structures, the maximized natural lighting and solar panels. Next, we have the cost for the environmental project. For the IFAS equipment, the cost is right around $9 million. The IFAS system is the nitrogen removal mechanism for the plant. The UASB reactor is the anaerobic digester chosen for the wastewater treatment plant. It costs right around $3.6 million to build inside the plant, but it is able to produce electricity for the plant to use, which offset the electricity cost for the plant. The operating cost for the plant over 100 days includes $156,000 for electricity without the UASB producing electricity for the plant to use. The electricity would cost $200,000 over the 100-day period without this. This project was funded by the state of Michigan, and required permits for the project were issued by the Environmental Protection Agency, and the required permit was the NPDES permit. Here we have the construction costs for the TechSmith building, starting off with the stormwater sewer at $102,000, our green infrastructure at $159,000, detention pond at $149,000, moving up to pavements where it starts to get a little bit more expensive at $1.4 million. And now the TechSmith building at a whopping $12.4 million. Now transportation is only around $43,000. This gives us a subtotal of $14.28 million. Now for some of our additional costs, We have design at $300,000 or 1.87%. Construction management at $500,000. This gives us a new total of right around $15 million. We wanted to add in a contingency of $1 million, which brings the grand total for the project to right around $16 million. Now we have the required permits for our job site. Over here on our left is the issuing agency, and on the right is our required permits. First we have our building permit, then our electrical, and we have our elevator permit because it is a two-story building, our mechanical permit, our plumbing permit, and now for our hydrology, we have the soil erosion and sedimentation control permit. We also had to remember about zoning, so we had to get our land use permit, our paving permit, along with our water and sewer connection. And we also needed to get our contractor parking permit. Transitioning from permits into the actual phase plan for construction. Phase 1, early site work, which will be done May 2022, July 2022. This phase starts May 1st and will help prepare the site for further development. This will include demolishing existing structures, clearing out the debris, and leveling the ground area. Grading, installing basic utilities which will be required during the construction process. Lastly, paving a temporary route along an area for the unloading of materials. Phase 2, which is June 2022 to December 2022. This phase is pretty crucial because this area of time sees its first snowfall. About 6 months from the start of this phase, the process of laying the foundation will start simultaneously with the utility work and go on until August 2022. After the foundation has been laid out, the steel work can be started. It will be important to have the steel superstructure built in time. This is by November, which will give about a month for the enclosure. Now, after the enclosure is completed is when interior work can begin, which can take place over the winter. Phase 3, April 2023. Once the winter season has passed, construction of parking lots, top course asphalt layer, and the process of laying the pavement will be started simultaneously. All these tasks are planned to be finished within 30 days so that the site is ready for Phase 4. Phase 4 is May 2023. Phase 4 includes adding the finishing touches to the building before it's ready for use next month, installing fixtures, appliances, arranging furniture, and required techs like CCTV and computers. Outside landscaping is also likely to take part. This document shows the phase plan from the last slide put on paper. As you can see, Phase 1 we have grading, utilities, and paving. In Phase 2 we have the foundation, steelwork, and enclosure, along with the interior work that comes after the enclosure. Then starts Phase 3 at the beginning of April, which had a top course asphalt and laying pavement. Then wrapping up the project comes in Phase 4, with our fixtures and appliances, landscaping, and design, and then the completion of the project. From all of us at Mitten Engineering, we would like to thank you for your time, especially the judges for taking time out of their busy schedules to be with us today. It is sad that we could not do this in person, but we still appreciate it nonetheless. Thank you very much.